All right, guys, in this video, we're going to be trying out this new tool from PropTech. It's their current tester, charging system tester, electrical system tester, and we're going to try it out on the CB750 to see if the charging system is working and stuff. What's cool is this hooks up to your computer. You run some software on it, and it has an oscilloscope and all kinds of stuff, and it gives you a bunch of data. Okay, so here's the tool that we're going to use. It's from PropTech, CT-01. All right, so it comes in this case, and what you get is this guy here. It's the current tester and a bunch of cables. So let's go through what these cables do. This guy here is the USB to hook it up to the computer. They give you just a negative battery cable lead, so in case you need to rig something up to make it pass through there, which we'll explain in a second. Okay, over here, this is for alternator testing. This is for a 3-coil or 3-phase alternator. And over here, this is the battery tester or charging system tester. This goes straight to the battery leads. And then this guy here, I believe, is for sensor testing, which I will not be able to do in this video since I don't have any sensors. Okay, so all these plug into here, depending on what you're wanting to do. And then one thing to note here is that the battery cable passes through here and this side to battery. So if the battery's right here, this silver sticker has to face the battery. Okay. You can also purchase some accessories. These are cables with voltage dividers built into it. There's resistors in here, and I believe that's for testing sensors. I'm not too sure, but in any case, we're not going to cover this in this video since I don't have anything to test. Okay, whiteboard time. Thanks to those suggestions on lighting in the previous video on the glare here, what I did is I put a softbox here, and I'm trying to illuminate or shine light on the whiteboard to minimize glare. I know one of you have suggested having a light up on the ceiling. Well, this was really easy to set up, and I think it's better. There's still a little bit, but anyway. So let me doodle a little bit. I'll fast forward through that, and then we'll talk. Okay, so really there are only 3 components in a motorcycle charging system. You got the stator, or I'll just call this alternator. That's what it is. It's an alternator that consists of a stator. The stator, as the name implies, stays in place, meaning it's non-moving. And then you have the rotor. Okay, I'll draw a little different schematic or a little different diagram of this later on, but that's usually how you see it in the electrical wiring diagram. Just a circle with like 3 things that kind of looks like a flux capacitor, right? Anyway, so that's the alternator. The alternator spits out power in AC, alternating current. Okay, that's no good for a motorcycle system because it needs to be DC, right? Direct current. So usually you have 2 or 3 wires. The motorcycle we're going to talk about here is 3 wires. So that's 3 separate coil windings that are generating AC power, and that leads to the RR or regulator rectifier. Okay? So what this thing does is first it rectifies the AC current. It passes through a bunch of diodes, which are like check valves for the electrical system, and it converts AC to DC. Okay? And then the regulator regulates the voltage. So anyway, we've got 3 wires coming in here. It's AC, and then it spits out DC, which can be used for the battery, right? So how the regulator works, actually, it has an output here, and it controls how much current goes to the field coil in this guy here. So if there's a drop in power or more power demand required by the system, this guy will spit out more power or current or voltage or whatever to the field coil to boost the output of the alternator. And I'll draw a different diagram on how that works. So basically, it's closed loop or it's a feedback system. So when the power demand goes up, this thing spits out more juice to the alternator for the field coil, and it'll bump out the power output. Okay, so there's only 3 things that could go wrong in the system. Obviously you need a good battery. If your battery's no good, then it's not going to charge, and it can give you... Okay, so obviously you need a good battery, otherwise nothing's going to work, right? You can test this component by testing each leg of this to make sure that AC power is getting output. This guy here is pretty hard to test. It's pretty complicated if you look in the service manual on how to test this guy. So if you have a good battery and you have a good alternator, you can usually say whether this thing's good or bad. Typically, you're obviously going to get an undercharge condition or overcharge condition, too little or too high voltage, and then this guy could be bad. But generally speaking, I would test the battery, then test this, and then finally that. Okay, so let me do a cross-section of the stator. Here's a stator ring, and this is front view of the motorcycle. Here is the crank. Okay? Let me draw that a little smaller. Okay, in here you'll have the rotor, flywheel, whatever you want to call it. So here's the crank. This guy is spinning. Okay? Actually, the rotor looks more like this. Okay, so this is a metal object. This is your stator windings. What they introduce is a field coil here. This is also windings. Okay, basically what a lot of these motorcycle manufacturers do is they create an electromagnet. So basically this is a field coil, which is nothing but a coil of wires. They apply a voltage to it and a current, and then they magnetize this hunk of metal, which is the rotor. And it has some goofy shape, and that's to get north and south poles on this rotor. So then you take this electromagnet, so this is now a magnet, and they spin it in these coils. Okay? And then this is where you get your AC output. Okay? So as you bump up the juice to the field coil, it creates a stronger magnet, more output from the stator. So they get feedback from the regulator to drive this guy to produce a certain magnet power to generate an output. And I'll tell you that electrical systems are more of my weakness, so hopefully I explain this okay. Okay, so here's what I was trying to explain on the whiteboard. Here is your AC generator or your alternator, and you can see there's 3 windings, okay? And there's 3 yellow wires that are coming out of here, okay? These are all carrying AC current. It goes to this rectifier, which has 6 diodes, and I'm a mechanical guy, so electrically all these diodes are check valves. It only allows current to flow in and not out the other way. So basically this converts it to DC current, and you can see the green and red wires coming out, which are DC, and that leads to your battery, right? Now also over here is the regulator, and you can see that the regulator will control current to the field coil. Okay, the field coil, if it gets a full battery voltage, it's going to allow this magnet to be the strongest, and it'll have the highest output for the alternator. If there's an over voltage, over current situation, the regulator is going to reduce the current or the power or the voltage to the field coil, and it'll reduce the magnet strength, right? Therefore, less power will be output by the AC generator or the alternator. So that's kind of how this all works. Okay, so the alternator on the CB750 is on the left-hand side. Here is the wire loom coming from it. And if we just quickly look at and see what's going on here, is I depinned this connector. Here are the 3 yellow wires from the stator. Okay, and then there's 2 other wires here that are for the field coil and whatnot. So what I want the field coil to still get the voltage so it'll turn on the electromagnet. So that's what we have here. And then what I'm going to do is take this guy here with the 3 yellow connectors, and we will test the output of the stator directly. Okay, it doesn't matter which they go to. Okay, so that's that. Make sure none of those are touching. And then this guy here will just plug into the tester. Oh, and if you're wondering how I depinned it, this is a little piece of sheet metal that I ground down, and it slides into the connector, depresses this little latch, and then you can pull the wire out. Okay, so I ran the negative cable through this tester. This sticker is facing the battery. The battery's right here. Here's my leads from the alternator. So we'll go ahead and plug that in the correct way. And then here's the USB cable. So I'll just go ahead and hook this up to the computer. Okay, so here's the software. I already entered vehicle data, company address, and then I went to function, and I went to alternator. Okay, so here we are in alternator mode, and what I can do down here, there's voltage 1, 2, and 3. So this is a 3-coil, 3-phase alternator or whatever. So I'm going to hit start, and we're going to start the bike up. It's cold, and we're just going to let it compile this data. Help if I turn the key on, right? Okay, I'm zooming in a little bit. Zooming in, just dragging the cursor. So here we go. Here are green, blue, and red. Those are the 3 RPMs or phases or whatever. Let me zoom in a little more. Okay, there we go. So here's my RPM all the way up to 4,000. And then here's volts. I got up to 30 volts on this guy. Okay, so the alternator's producing voltage. It looks good. All phases are equal. So this test looks pretty good. Okay, for the next test, I put the wires to the alternator back into this connector, and we're just going to put it back to stock. It's going to charge the battery, and then we're going to hook up a different set of cables directly to the battery and test the charging. Okay, so the alternator's good. Let's go to this function, normal. Okay, and we're going to just do a battery test, charging test, and I'll show you how to hook up the cables now. Those are different cables that go directly to the battery. Okay, so we're using this harness now that has the black, red, and the blue. The blue we're not using. Black goes to negative, red goes to positive on the battery, and then hook up this harness directly to the tester. Okay, and then this is going to just do an overall charging system check. Okay? Okay, so per this instructions, we're going to turn on the ignition. First, we're going to hit start on the software. We're going to turn on the ignition. We're not going to run the engine yet. There are some models that have fuel pumps and whatnot, and switch the headlight on. I don't have a headlight hooked up, so we can't really put a load on this charging system. You really want to do this to test under load, will the system charge, right? Well, I can't do that, but in any case, let's just continue. Start the engine, let it idle for for 5 seconds, and increase RPM to 3,000 RPM for 3 seconds, and then let it idle for 2 seconds, and then stop the engine. And then we're going to look at the chart here. So let's go ahead and do that. Make sure we're in normal. We're going to start. Okay, so I'm starting. That's the ignition on. Obviously, looks like there's a little voltage dip because the ignition's on. So let's go ahead and start this. Sorry, the engine's cold here. Okay, so here's the data after it's been recorded, and there are some check marks here. So the red is voltage. Okay, right here you have the volts. Voltage is in red, and it looks like we have, if you right click here and say show point values, you can highlight the values. So right here I'm sitting at 12.6 volts. At this point right here I turn the key on, right? So we have a voltage drop because the ignition coils are pulling some amperage. They're turned on, so I'm at 12.4 volts. And then down here, I drop to 8 volts during starting. That's typical, right? Then it comes back up, and I think it died out, and same thing goes. And then over here, this is where I increase the RPMs, and it climbs to 12.67 volts. Okay, and then here we have idle, 12.4, and back up to 12.6 after I kill it or shut it down. Okay. In blue here is the current, so we have a current spike. This is the 0 line. Anything above here is consumption, so it's consuming current, and it looks like we have up to 230 amps for a short period during crank, and then I would say the average is around 50 to 60 amps in here as it's cranking once it initially gets past that. Okay. Let me go ahead and turn the voltage back on. Okay, so what I want to do is zoom into here. This is where I increase the RPMs and I want to see if it's charging. Okay, so we're going to zoom in this area and take a look. So you just click and drag a little window, and there it is. Okay, so right now we have 12.6 volts, and then down here, look, the current is pretty much at 0, or actually above 0. So I am actually consuming about an amp versus charging. If anything was charging, it would be below 0. Okay? So this really should be much lower. Okay, I should see a negative value, which will mean it's charging or putting current into the system, and it's not. It's not charging. The voltage is increasing a little bit, but the current, it's pretty much consuming. So that's not ideal, right? Something's up with the charging system. Okay, if I right click, I can go to unzoom, and I'm back over here. So voltage is on this axis, so is RPM, and then here's current. Okay, so that tells us that it's not charging. Let me bring up the service manual real quick. For this CB750, and here's a diagram of the rectifier, the regulator, the alternator. Here is some information, and I did check this. There's stator coil resistance, field coil resistance, but we know the alternator's pumping out 30 volts AC, which is should be good. I really wish there was a specification on AC output, because then we can compare it to that. But in any case, it's a 13 amp alternator, so that's the power output it's capable of. Okay, so here's a diagram that we can compare to. So I was at like 4,000 RPM, and you can see that this is really confusing. They got a night riding and a day riding. So I'm assuming that during the day, the lights are off, and that's the current we should see. And at night, you obviously have the lights on. I don't know, it's kind of hard to determine what they're trying to do. But in any case, we should be anywhere from 1 to 2.5 amps that the system is adding or charging to the system. And it should be at 13.2 volts. So clearly, if we go back in here and we zoom in here, we should be anywhere +1, or I mean, in this software, we should be -1 to 2.5 amps that it's adding to the system. And up here, we should be at 13.2 volts. Okay, and this is testing it with just the ignition on. We don't have the headlight on or any of that because this electrical system is not complete. And the purpose of this video is to show this tool, not to fix it. Okay, I just want to point out things. All right, so that's that, and then here you can have all kinds of other tests and whatnot. Okay, and then up here it says the resistance of the battery, 18.2 ohms. 3 to 10, okay. 10 to 15, passable. 16 plus, have to change. So this is a new battery. I'm not sure why I have such a high resistance here or whatever, but that's something I need to look at. Okay, so over here we got the regulator. Here's the rectifier. This is a 40-year-old bike, okay? And this electrical system needs work, obviously. All the terminals have a little bit of oxidation on it. They should be cleaned up. I didn't do any of that. So obviously, a non-charging condition doesn't surprise me, okay? I took the cover off the regulator just to see in here, and this regulator is actually adjustable, okay? So there's that. One thing I want to point out is if I look at my battery voltage, okay, it's 13 volts, and my battery was a little low during the charging test, okay, so I should have charged it. But anyway, we should have seen a current. We should have saw current adding to the system. Even if I saw low voltage, and if I saw 2 amps being added, then I'd be okay with that. But there's no amperage added. So anyway, if I turn the ignition on, it drops down to 12.7 volts, right? Now, if I go from here to my regulator, okay, this is ignition. All of a sudden, look at that, 11.5 volts versus 12.5 volts. So I have a volt drop just in the wiring and all the connections back to this guy. Okay, that was the ignition wire. So right there, I would look at that and see what's going on. Okay, and when you open up these connections, they're all a little oxidized and whatnot. Plus, this is all 40 years old. So I'm not sure what's up with the non-charging condition, but obviously you got to go back to square one. Connections, make sure they're clean and tight. I didn't do that. And then maybe some of these components are suspect. But in any case, I just wanted to show you this PropTech tool and how it works. And it did say, hey, the alternator's good, but something's going on here. Okay, and that's where I'm at with this thing right now. And in a future video, maybe we'll look at what's needed to fix this. But obviously, I got a lot more work to do here as far as the electrical system is concerned. Okay, if you're interested in this tool or finding out more info, I'll leave a link in the iCard and in the video description. You can check it out for yourself.